Hello and welcome. Good afternoon. Welcome to this PV Magazine Insight on Quality event. Thanks so much for joining us. My name is Jonathan Gifford. I'm the founding editor of PV Magazine Australia, and I'll be your host today. Thanks again for joining, because I hope our program will really bring you lots of insights into an issue and all the related issues. That's a really important one for the Australian solar industry. And we really have some legends of the Aussie solar industry joining us today, along with a great selection of international experts. Before I go any further, I'd like to thank the Clean Energy Council and All Energy Australia for hosting us again this year, and to our event partners, Ariel Ray, Biwa, RE Solar Systems, Clean Energy Associates, Longi, Scholes Technologies Group, and Stoibli. Well, we've divided today's event into a number of sections, and I'll just give you a quick look at that now, although I'll go into a bit more detail very shortly. But the big question that we're addressing is, what can you do when rooftop solar systems underperform? Where does it leave the installer? Where does it leave the supplier, the wholesaler? And how can these risks be mitigated? To give you a little bit of background about these quality events that we've been hosting at PV Magazine since 2015, we've been doing them at major solar trade shows right around the world across 6 continents so far, and we've been part of All Energy since 2018. What we do is we base our discussions on real-world case studies, and it's not about naming and shaming suppliers or different industry participants. It's really about sharing our real-world experiences when things do go wrong and trying to learn from them so we don't let down investors and our customers of the solar industry. And I want you to get involved today. So please jump in at any point and ask questions of myself or any of our presenters or panelists, and I'll feed those questions into the discussion. One question we always get is, will the slides be available after the event? And absolutely they will. You can access all of the slides and a recording of this session from pvmagazine.com after the event. Now, what is the problem? What is the challenge that we are addressing in this event today? Well, I think the really good news is that the Australian solar industry is in pretty robust health despite the COVID epidemic. Figures here from Green Energy Markets give us an insight, and of course the powerhouse being the rooftop segment. And of course, as we know, rooftop system sizes in Australia have been increasing pretty rapidly. This is a historic chart again from Green Energy Markets, just showing how systems are going bigger. People are maxing out their rooftops. More and more small businesses are turning to solar for their energy, and some of these smaller systems that were installed under the various state feed-in tariff schemes are very much phasing out, a thing of the past. So this is all great news. Systems are getting bigger. We're installing more solar than ever before. But this is also the question: what kind of liabilities does that result in? And this is a real world chart from publicly available monitoring data that really shows, the dark gray here at the bottom is energy production in year 1 of the array, in the light gray, my apologies. And then the dark gray is 4 years later. We can see that the system's production has dropped off quite significantly. Also in the early morning, which is really when you want the system to be producing as people are waking up and getting about their day. So what do you do if this customer, maybe they get a shock on their bill, they're not monitoring closely, maybe they are monitoring closely, and start to see their power from the PV system start to drop off? What can be done about it? How can the faults be detected? How can things be turned around? How can they be detected? Module level monitoring is a pretty powerful way of getting more insights into what's going on the modules themselves. This is a little schemata that we've drawn up, but this is real world data. Here we can see module level monitoring on a relatively small rooftop system, but we can see over a period of 3 years that the power output from the modules is really dropping off significantly. And this is another indicator, or another level of insight into what might be happening if degradation is occurring. And we will be digging into degradation in quite a lot of technical detail throughout today. Another tool that's available to installers and to our whole community in terms of fault detection and analysis is imaging, whether that's thermal imaging or EL imaging. And this is a nice example of some drone images that were taken from about 20 meters off the top of a rooftop array. And we can see how both the thermal imaging and in particular the EL imaging gives us some insights into how PID, potential induced degradation, is impacting not only a system, a section of this rooftop array, but also a string. And I think that's really interesting to show the level of insight that can be gained from this kind of imaging. Once again, I said we're going to be breaking down the event into 4 kind of subsections. First of all, we're going to talk fault detection and analysis and answer some key questions there. Then we're taking a really deep dive into module degradation. The module still makes up a big chunk of the system cost, and of course, that's where the power comes from. So we'll look into some different degradation effects and the latest research really on one of the newer effects that we know perhaps a little bit less about. But of course, it's not just the module. We'll also look into BOS components, and we have some international experts to give you some insights there. And then the business side of the equation. Warranties, how can we claim against manufacturer warranties or perhaps even performance warranties? The role of the distributor, key players in the Australian market. What does that mean for in terms of risk mitigation and quality control? We're also going to look at liabilities and potentially the role of insurance, which I think is evolving quite rapidly in the global PV markets. Well, I did mention monitoring and module level monitoring, but I think let's dig into a little bit more of the data in terms of monitoring. Our first speaker today really doesn't need too much of an introduction. I once heard one of the Solar Cutters guys say that Nigel owns shoes that are older than him, which I think is a little bit unfair, but he is very much a legend of the Australian solar industry. He now heads up business development with solar analytics, but he has a long history in PV production right back to the BP solar days. Nigel Morris, thank you very much for joining us today, and I'll pass the floor over to you.
Hang on. Then I can unmute and I go back to request for remote control, and now I should be good.
All good. Thanks, Nigel.
You got me now? Okay, good on you. Good day, everyone, and thanks to the sponsors. Always big shout out to the sponsors. They put their money on the table. I'm jumping right in here to a quick introduction. I won't talk about our company too much, except that with 44,000 sites out there, more than that now, in fact, nearly 45,000, I think, this week, we've got a really good insight. And with about 900 dealers out there, we've got a lot of diversity. We're on large-scale multi-megawatt sites and loads and loads and loads of small sites. So with that, we have great insight into data. What I'm focusing on today, of course, is, you know, particularly around warranty and performance. What does this actually mean? And what can we gain from this? I am going to just see if I can get this to proceed. And there we are. There we are. Thank you. Sorry, a little bit of lag there. So how do we do it? In our case, we do it a number of different ways. And in fact, that's expanding all the time. We've got very, very flexible 4G hardware that's been our sort of staple, our bread and butter. We can also detect what's going on with solar systems via Modbus to 4G hardware. Increasingly now, we're also doing inverter wireless to API. And of course, also getting data from other sources, from inverters, from meters via 4G or API. So there are a lot of different ways that we can get data, both on generation and consumption. It goes via a device of some type to get up to the cloud. We then apply a whole lot of algorithms and control, and then send that data to an app that allows users and owners and installers to see what's going on. I'm still having trouble getting this slide to proceed. Oh, I need to click on the slide, I think. And there we are. Now I've got a little control thing. There we go. My apologies. So just to set the scene very, very briefly, there's some great data. It's a few years old now, but this is universally kind of applies and hasn't changed very much. This data was from a big study done in Queensland. And in simple terms, it shows that, as time goes by, the likelihood of failures increases. That's no big surprise to anyone, but it does take a while for these faults sometimes to appear. I think it's also interesting to note here that the vast majority of faults recorded in this survey, at least, which is pretty representative of most, is around the inverters. That seems to be the weak spot. I think the other thing that's really interesting out of this same set of survey data was that obviously the harder you look, the more you'll find. And so this is a sample of frequency of people looking at their system. And of course, the more eyes are on that system, the more you are going to probably detect problems. I also wanted to set a scene here by going in and looking at our own fleet. And in fact, the other day I downloaded a data set from our entire fleet of around 45,000 sites. It includes some very old sites and includes some very, very new sites. But I think the one of the key issues here is that in terms of how we determine what's going on for using our own analytics and diagnostics, when we look at our fleet, we can see that about 70% are good. This changes on a daily basis, hourly basis, in fact. So this changes, is very, very dynamic. But we can, using all our maths and algorithms and good logic, we can determine that we reckon in this case about 70% were working fine. There are about 22% that we reckon, there's something going on. We don't quite know what it is, but we can definitely detect that something's not quite normal. So we've sort of tagged them. We can see that some have comms faults, devices drop in and out from time to time, especially the older ones. And in this case, only 1% of our systems in black and white terms could we actually determine had a fault when I looked at this data. These will move around. They'll move from category to category as our diagnostics and algorithms do their thing, of course. But this gives you a pretty good representation. Just to add some more qualification to this, we recently had one very, very large customer of ours with a fleet of several thousand sites who said, look, we're a bit worried that we've got some issues going on within our fleet. We've got some alerts and notifications coming out. Could you have a look? When we looked individually at their fleet, which was about 1,300 odd sites, we had almost exactly the same breakdown. So whether it's an individual fleet or whether it's the entire fleet, we see pretty common statistics. So we think this is probably indicative of what's going on out there in the market. So when it comes to actually solving PV warranty issues, the thing that I've learned, and you're going to hear from lots of very, very esteemed experts with lots and lots of expertise in different areas, so I won't try and usurp them, but there are lots of moving parts, and ultimately, when it comes to a warranty claim, it starts with one simple thing. It starts with either an angry customer or monitoring alerts. They're the only two reasons, they're the only two ways that a warranty issue can ever start. It's by someone saying there's something not right here. And then, of course, there's a question of what happens next. What happens next is someone has to work out, is it really a problem? Is it genuinely a problem? They also have to work out, okay, if we think it is a problem, how do I get evidence of that? Where do I get that evidence? Where is the information that I need to go and fight a claim or argue a claim or whatever the case may be? How big is the problem is the other thing that, of course, everyone wants to determine, because if it's not worth worrying about, you're not going to worry about it. If it's big and costly on a commercial facility, for example, then different case. The last question then, of course, is what's required to fix it. So then it's worth stepping into the action mode, the diagnostics mode, and trying to work out what to do. When I was thinking about this, though, of course, it can go beyond just those four things. Is it a problem? How do I get evidence? How big is the problem and how do we fix it? But there are other questions that are often asked, and that is how and why did it happen? Progressive, forward-thinking, highly involved installers or retailers will often try to get to the root cause so that they can take some preventative actions. Businesses, of course, quite logically and reasonably will ask the question, is it indicative of something systemic? And is there a risk for my business that I need to be considering here? And of course, am I getting the support that I expect from my suppliers? So there's a lot of moving parts, and at the end of the day, from everyone's perspective, getting involved in a warranty claim, of course, at some point or another, is going to involve a whole lot of data. So let's talk about these key things. And again, this is a sample from the other day when I looked at our average fleet. So is it really a problem? So there's a bunch of tools that you can use, a variety of different monitoring techniques. Jonathan mentioned module level monitoring services. There's services like ours. There's a whole lot of different techniques that you need to use, but at the core of it, you really need to get down to it and say, how big is the problem? Where do I get that evidence? And I'm looking at this as an example of what data can show you. And in this case, what we're trying to demonstrate is that, you know, from a fleet perspective, for example, you can look at individual sites, but you can also look at fleets of sites and say, is this site behaving abnormally compared to other sites in my fleet? From there, of course, we start diving deeper, and this is what often happens, has to happen. This is a snapshot of actually a brand new dashboard. So it's a sneak preview here, which we're about to release, that looks at severity ratings, for example, to help businesses understand, okay, this is something I really need to act very fast on because it's very severe. However, this one's just something to watch, perhaps, because it might be indicating a trend that we're starting to see. How long has the fault been going on? And then in our case, what we're also trying to do is trying to help with diagnostics and action. So what can you do about it? Who do you go to? Who installed it? Et cetera, et cetera, et cetera. Is it a performance issue, or is it an outright fault? There are all sorts of things that you can use diagnostics tools to help you with. And a reminder, of course, that all of these things are highly dynamic. We see faults come and go. You'll have networks that go up and down. You can have extreme weather events. We had one in Brisbane the other day, which was which showed up on a lot of sites. Performance is an area that we really focus a lot of attention on. And performance is really the crux of all of this. What is normal? That's the question. What is a normal system? What should it be doing? There are around 20 variables. I'm not going to read through them all, but there are a huge number of variables that can make a system perform. Yes, Frederic, I will wrap it up. I saw your message. Thank you. I'm going to be very quick now. So there are lots and lots of variables. There's a complex bunch of sums that we use with algorithmic smoothing and a whole lot of other things, but there are all sorts of variables that can make a normal system behave abnormally. Some are typical things that you'll see, and some are not. I'm going to skim through my slides, but obviously long-term trends are something that we look very hard of. This is an example of how we can see some of those long-term trends. Site specifics obviously come into play, and we really believe that data granularity really helps. We can go down to 5-second data as an example. We can go into circuit level monitoring. These tools can be used to help rule causes in or out, which is the key. And of course, testing solar modules, there are all sorts of variables around testing solar modules. There's equipment tolerances, there's accuracy and calibration requirements. There's all sorts of external factors that you'll hear from a whole lot of PV experts later on. I've gone over time. I thank you for your interest. I hope that helps.
Thank you, Nigel. I just see a bit of a frozen screen, but so I'll keep pushing forward. Thank you very much, Nigel Morris from Solar Analytics. So a lot of variables that can be kind of shown up by monitoring tools. Interesting to see that the inverter is frequently a cause of failures, but let's go further into the module while we're talking modules. Our next presenter is George DeLupas, who has a long history in PV manufacturing, on the technical side, also on the technical side of project development, but now he is the Director of Technology at due diligence and engineering provider Clean Energy Associates. George joins us from Athens today. And George, you're going to provide us some insights into degradation and some of the issues that Nigel raised in terms of collecting information and making a warranty claim. George, over to you.
Hello, good morning and good evening to everyone. From Athens, it's pretty early here, but I'm very glad to be on this session, another, let's say, quality roundtable, which I've been attending for the last few years with PIV Magazine. Very few words. Trying to get this to advance. On Clean Energy Associates. It's a technical advisory and quality assurance company. We've been around for more than 12 years, more than 135 professionals in 12 countries worldwide, physical presence, and a very impressive 65 plus gigawatt of track record and experience for solar and storage projects. So, what is it? The famous PV module degradation. How is it defined? So, could be two ways. One is to take the maximum power of a module, sorry, the nominal power of the module at as it's labeled from the factory, and then measure the maximum power at a later point in time. And this is the difference, the degradation. And of course, the module has power that should be higher than the maximum power. And that's the second definition. But of course, this is very hard to know. So what is standard is that the manufacturers prefer the first method, the nominal power, first definition. The modules have positive tolerance, so by doing the first definition, we're losing some wattage there. But this is how the market works. And now the typical warranties, which, by the way, they're all industry-leading, labeled, start with a very steep first-year degradation, 2.5%. Now we're seeing 2% after the introduction of gallium-doped wafers. And then they keep going with around 0.7 or 0.4%, which is like the best in class, usually given for utility scale glass class modules. So, but if we look at what might happen, so there's a bit of a lag. Okay. When we see a problem, we're trying to measure the power and see if we can, file a warranty claim. There is this so-called measurement uncertainty, which is there, and it cannot be gotten to zero, unfortunately, even if the lab goes into great lengths to calibrate the flasher and use reference modules and do all kinds of corrections, which of course increase the expense of measurement. So what happens is that typically in the warranties, all the manufacturers are asking for the testing equipment, they call it tolerance, but it's really the measurement uncertainty to be applied on top of what is measured. So if you look at the graph on the right, we have the blue bar, which is what we measure, the green bar, which is what is warranted, and then the red bar is what we measure plus the uncertainty. So and then you're looking at the lines, so the green dotted line is, let's say, the warranty curve, degradation. The blue line is much higher, so we have a degradation problem, but we have to subtract, let's say, the uncertainty, and we end up with a red line, which is below so within the warranty, below the warranty degradation. So this is a factor. Of course, 4% is pretty high, but again, if we are using an IV tracer on the field, that's pretty high. It's 5% even more. If we go to a really good lab, maybe we get 2 to 2.5%, but getting lower than that can be very, very difficult and expensive as well, because we have to measure quite a few modules to get that. So why do modules degrade? It's a natural process. So everything dies eventually, including modules. It's not linear. This is an abstraction. There are lots of things can go wrong. But of course, we have to avoid the early infant failures by doing the necessary steps. But even then, we might see degradation coming in midlife of the module. This is from IEA's PVPS document. We have added LeTID, which was not known, if you have not this one. And it's typically pretty difficult to detect and file a warranty claim. And degradations like all the Ds, let's say, potential induced, light induced LeTID are not considered as manufacturing defects or serial defects. So everything has to be negotiated, including sampling, etc., from the manufacturers. And the buyer takes up the costs. So in this case study, we're looking, we're looking at the buyer who has several PV plants, and we have actually found there is degradation, underperformance. We found some telltale effects where checkered EL image patterns have been detected. We have excluded PID or even LID or mixed power classes because there has been quality assurance during the production, and we've done all the testing and the checking of the modules. So everything has been excluded. So the very probable root cause is the LeTID. And by doing some lab testing, we're able to identify that the spare modules degraded and the degraded module regenerated. So right now we're in the process of negotiating with the manufacturer of remedies. So even for very difficult degradation causes, there are ways to go around and do the diagnostics and get the warranty claim in a course. Thank you.
Thank you very much for that, George. Interesting to see some of the LeTID effects, and we'll be going into a little bit more detail on that. I see that some questions have come through for Nigel and that he's answered them on the chat. Thank you very much for that. And also, please feel free to ask questions at any time of any of our panelists. At this stage, I'd like to bring Michelle McCann into the conversation. She's in partnership, runs the Canberra-based test lab, PV Lab Australia. And as George set out earlier, or just a moment ago, testing has a key role to play in terms of making warranty claims. Michelle, thanks so much for joining us today. I'll kick off with a question to you straight away. We've seen some evidence of LeTID in some of the examples that George provided. How much have you seen that, of LeTID or these kind of degradation effects in the modules that you've been testing in Australia?
Thank you, Jonathan. And yeah, a pleasure to be here today with everyone. Great slides from George and Nigel. And Nigel gave a little mini introduction to our lab because that was a picture of me and part of our laboratory at the end of his presentation. But just by quick background, so we test panels kind of in two different ways. Firstly, we test panels that are new and fresh out of the box prior to being installed or just after installation. And we do that either in our laboratory or in situ. And then we also can test panels again, either in our laboratory or in situ that have been out in the field for a couple of years. So in the case where the modules are new, any tests that we would do are looking at the susceptibility to degradation. And in the case where the modules have obviously been outside for a while, the tests that we do are looking for degradation effects. And so I can say that we have seen degradation in the field after just a couple of years on old panels. In terms of susceptible panels, at the moment we've got an almost commissioned PID testing chamber. So since it's almost commissioned, we haven't actually seen any panels that look like they'd fail, but I suspect that early next year when that's up and running, we will start to see panels that are susceptible to PID degradation in any case.
Okay, well, George set out one case study where the module maker had some modules that had been set to one side for testing at a later date, these kind of spare parts or replacement modules. How important do you think that is as a strategy for installers or wholesalers if in the future they have to make or want to make a warranty claim on the basis of degradation?
I think it really depends on the size of the installer or the importer and the size of the panel import that they're doing. So, you know, it's a great idea, and it's a great idea for lots of different reasons. And the case study that George showed, it proved to be really useful. But I'm sure that George would also agree with me that our job is both more pleasant and more effective if we're testing panels a lot earlier in the process. And the value that a test lab can bring is really in avoiding that kind of confrontation as best you can, because once you get to that point, it's costly, and it's costly in terms of time and money, and of course very emotionally draining on all sides. But you know, if it's the last resort and you've done all the right tests at the beginning, or for whatever reason you didn't, then it's great to have as a backup, and it can really resolve some issues.
Okay, we also see higher powered modules. That's kind of a feature of the solar industry. More efficient cells, and in all sorts of different module designs. How much complexity does that introduce for testing in terms of kind of capacitance effects and these kind of things? Does this mean that there's a wider margin for error?
I think it can, depending on the way that you test. It doesn't for us in the way that we test. Yeah, we use without getting too technical, we use very narrow sweep ranges for our panels, so we're not bothered by all the different panel varieties and ranges of module classes that are out there. But it is, you know, it's a thing for the industry. The manufacturers are introducing multiple new product lines every year, and when we talk about, just going back to that earlier question about keeping spares, that's going to be really tricky if you're not importing a whole lot of the product to start with.
And so what kind of, you know, I imagine installers, we're talking about the kind of handful of megawatt numbers, maybe perhaps less than 10, maybe for a bigger installer over a series of years, 8 or 10 megawatts. Is it feasible to keep a small number of spares for testing at a later date under those conditions?
Well, you certainly would for a farm. So I'm involved in a farm that's of that size, and we've got spares on hand. But if you're doing rooftop installs, then I would think I mean, you need to have the space and the capacity to store them all. And if you're importing that much each year, obviously you're increasing the amount of storage that you need. But it's also not a very good first line of defense as a small installer against issues that happen later on. Like, a first line of defense should be checking what you're buying on a regular basis, and preferably before you've paid full price for your panel, so that the small amount of power that you do have, you can wield at that point, rather than getting into these kind of messy situations later on. But if you are, you know, building hundreds of megawatts, then it's easy to have a small shed on site that's got a couple of spares in it.
Okay, I have a question about thermography. Will thermography be recognized as a certified PV module inspection tool in the foreseeable future? How much can we rely on thermography? Perhaps George, you would like to jump in on that one?
Well, thermography can be a very powerful tool, although it's limited. So if you want to do much deeper analysis and diagnosis, electroluminescence imaging is more powerful. Of course, it's more difficult to do because you have to energize the strings, do it at night or even at day. So it depends on the issue. You can really find the low-hanging fruit much more efficiently and cheaply with thermography. It's the par excellence tool that is being used for small and very large systems today.
Okay, and one more question about microinverters. Are there any other methods for module level monitoring other than microinverters?
Optimizers.
Optimizers. Okay, so all module level power electronics.
Yeah, also there are power electronics that just do monitoring that can be incorporated in the junction box. I think Tigo has some varieties. But overall, yeah, it's either optimizers. There are very few companies that do them, by the way. Most famous one is SolarEdge, and microinverters. Okay. Which is, by the way, for residential, it's what we call a no-brainer. When I started in Greece 10 years ago, I was mostly installing optimizers for like peace of mind.
Mm-hmm. Yeah, to give you that insight. Of course, there are quality issues with putting power electronics up on the roof, but we'll save that for another day. Michelle, just one last question. How do you find that kind of module level power electronics data compares to testing data? I showed a slide before that seemed to show some module degradation on that from the MLPE. What do you see when you compare that to test data?
We haven't done a lot of direct comparisons of those in-field measurements to test data. I think George mentioned earlier that the lab testing is a lot more accurate. Yeah, so certainly that kind of stuff's good, and it's great for getting a first smell on things and an idea if things are failing. But yeah, if you really want to work out if it is failing in a way that will convince a manufacturer to uphold a warranty claim, then obviously you do need to go back to a lab and have the measurements done there.
Can I just add something here?
Oh yeah, please.
Yeah, we have our test site in Xi'an with PV Magazine, CA is involved. So when we set up the installation with lots of different modules, we used optimizers from Huawei actually, but we didn't trust their measurements, so we installed specialized meters to get accurate measurements. So this equipment is not made to produce accurate measurements. So you should really be careful of that.
Yeah, okay, interesting. Gives you an idea and perhaps peace of mind, but won't really help you when it comes to a warranty claim. George Taloupas, Michelle McCann, thank you very much for joining us. We will keep going. I see that Nigel Morris is very active on the chat function, so feel free to ask questions of any of our panelists. I'll try to feed them into the discussion and also the chat function on Zoom. Thank you very much, and let's keep moving and looking into degradation effects. Thanks again, George and Michelle. Well, I think it's pretty safe to say that technological change within the PV sector has never moved so quickly. And that makes the role of R&D teams and our PV researchers more important than ever before. And in Australia, we're really lucky to have a large number of high quality PV research institutes, but I think very few in the world come as close as UNSW in terms of a global and long-term reputation, and that's where our next speaker comes from. Alison Chiesla is from UNSW, and you can very much say that PV research is in her blood. She's been part of a team that's been doing world-leading research into LeTID and other degradation effects. And Ali joins us now to provide us with an update. Alison, thanks so much for joining us today.
Thanks, Jonathan. Thanks for that amazing introduction. I think you talked us up a lot more than I probably deserve. But today I'm excited to talk to you about LeTID because it's something I've been studying now for a few years, as well as LID. So today I'll tell you a bit about what we know from research. Oh gosh, why can't I? Did that work? Oh, there we go. So LeTID stands for light and elevated temperature induced degradation, which essentially just means that it forms in sunlight. It's unlike a mechanical failure type of degradation. It's an electrical defect that forms within the solar cell. And it's similar to a previously well-known degradation mechanism known as light-induced degradation, which was formed by a boron oxygen defect. And there's now well-known commercial solutions to solve that using hydrogen. But we now believe that that hydrogen that solved the boron oxygen defect is causing this new degradation known as LeTID. the degradation can be significant, can be more than 10% power loss, and it can affect the module for essentially its whole life. It's a very slow degradation, as George already mentioned. But he also mentioned that it varies depending on temperature. So if we increase the heat and illumination, we can accelerate the degradation. So this obviously has implications for what you would see in the field in different climates around the world, but it also means we can accelerate it in the lab to look at what would happen in the long run. And when we test at higher temperatures, sorry, I'm having some troubles clicking screens. We can actually see that if we accelerate it enough, we see a full degradation before essentially a full recovery under the same conditions that cause the degradation. So what else do we know about the degradation? It's very, very variable. Even minute changes in cell processing conditions can cause drastic changes in the behavior that we then see. So if we look at the change in voltage of these cells that have undergone thermal treatments with only 15-degree difference, you see some degrade very quickly before recovering quickly, while some degrade quickly before recovering slowly, and others just degrade slowly indefinitely. So it's therefore not surprising. A recent study was done testing a number of modules that found that the degradation was highly variable between different modules made on different wafer types or different cell technologies, and similarly, very different degradation even on modules made from the same wafer type and technology. It's also very variable due to different conditions. And surprisingly, I just saw in George's slides, he mentioned that with higher temperatures, we see more degradation. But in actual fact, recently what we've seen, I studied 4 different manufacturers' modules at different temperatures. These are from the market 2 years ago, so they're not the most recent modules. But what we saw is that some of the modules showed the same amount of degradation no matter what temperature they were tested at, and some actually showed increased degradation at lower temperature, which is more representative of the majority of field conditions. So that is quite surprising, but also makes it much harder to predict what will happen in the long run. The other thing you'll notice is that all of these manufacturers I tested have very different amounts of degradation. And the only one that could be considered stable would be manufacturer B. They would be the only one with a treatment. And I would hope that if I tested modules from the market in 2020, much more would have stable or minimal LeTID as that manufacturer does. We now know of multiple ways to treat the degradation, and some methods can be as simple as a thermal process that can be applied after the cell is even manufactured, which is much easier to apply before the cells are encapsulated into the module. So manufacturers of modules who buy cells imported can actually apply a treatment to make those cells stable prior to encapsulation into a module to ensure they would be stable. But again, due to the variability, these types of treatments need optimization regularly every time a process is changed in manufacture. But so what impact will we see in the field? All parameters of the modules are affected: current voltage and fill factor. I've briefly mentioned what will happen in different climates, but essentially in a subtropical climate like Queensland, you're likely to see a maximum amount of degradation within a decade before it starts recovering. Whereas in a cool temperate climate, more like Tasmania, it's likely to just degrade over the whole life and never fully recover. Well, that's just a simulation. I'll skip over that in the interest of time. But this is a particularly interesting study that came out recently looking at 6 arrays of modules from the same type and manufacturer in America in a fairly warm climate. And 5 of the 6 modules arrays degraded fairly significantly. But interestingly, it's hard to detect this in the short term because of the huge uncertainties mentioned by George, as well as weather fluctuations and all kinds of things. You really need multiple years to detect this, even in a warm climate. But that's not to say it's not significant, and it will cause a significant amount of power loss over the life of the module. So testing is now becoming a thing. So TUV Rhineland, I know, offers some certification, which will provide some confidence that there is not excessive amounts of LeTID, and there are new IEC standards on the way. But these standards are all a bit limited in that they are sort of pass-fail. And these modules that only degrade about 1% per year are likely to slip through this test and be considered a pass, but yet we don't know from this what the long-term degradation might look like. This could still be really significant over the life of the panel. We don't know what the recovery behavior will look like, whether it will be quick or slow, and ultimately what the impact is. So this is a huge issue that we still plan to study a lot, and we've actually got a new tool on the way, a custom-built climate chamber with integrated IV coming from Eternal Sun in the Netherlands, that will be the ultimate test for us to be able to test this type of degradation, and will become increasingly more important as cell efficiencies are higher and new cell structures come out, as we're likely to see new degradation modes forming within cells. And so this is something we're excited to study, but also perhaps some way we can offer a sort of diagnostic or test maybe to the industry to be able to help identify these problems. And yep, that's done. Sorry, wrapped up. Thanks, Frederica.
Perfect. Thank you very much, Alison. It's kind of equal parts encouraging to see progress being made in manufacturing, but also a little bit terrifying to see how much we still don't know and how very differently LeTID can affect modules in different climates, and they may not recover at all in certain climates. All right, Ali, I'll ask you to stick around. Please feel free to send questions through to Alison, either on the chat or I can feed them into the discussion. This is a great opportunity to ask questions of the experts. Now, Ali mentioned that manufacturers can put solutions for LeTID and other degradation. I think George already mentioned gallium doping in production for LID. Let's hear from the manufacturers themselves. I think LONGi is a very familiar manufacturer and has risen incredibly quickly in global PV markets, including Australia, taking very big market share, aiming for 1 gigawatt of shipments in 2021. One of the drivers of a number of technology trends, including the shift to mono. LONGi has really played a prominent role also in that, but also in the shift to larger wafer sizes. Richard Kian has been with LONGi for a number of years and has also worked with some pretty famous names from the solar industry, TÜV Rheinland, Solar Juice in Australia, and he joins us now to give us an update as to what the manufacturers are doing, and in particular what LONGi is doing to tackle the issue of degradation head on. Richard, I'll pass the floor over to you.
Thank you, Jonathan, and thank you for inviting LONGi to be part of this session. And it's an honor to be sharing the panel with the rest of the experts as well. So good afternoon, everyone. Let me just offer my 2 cents in this matter. So there are different kinds of degradation that the industry has discovered and studied. For example, the degradation caused by aging, potential induced degradation that has been well understood and tackled. And of course, the most discussed and challenging LID, which is mainly due to the boron oxygen complex within the silicon wafer. And also the LeTID, which we still need to understand more its mechanism. And luckily we have researchers like Dr. Alison Chesler and her team dedicated to these 2 major issues that the mono technology in particular has been facing. So one of the advantages from a highly integrated manufacturer like LONGi is that we can control and manage risks in every single stage, from wafer, cell to module manufacturing. We have been committed to monocrystalline silicon for over 20 years, and a lot of R&D effort has been put into overcoming degradation. For example, we teamed up with the UNSW to commercialize the hydrogenation process that can effectively mitigate LID. This technology has been employed since our first generation mono module product, HIMO 1, back in 2017. At that time, we could already offer a industry leading low degradation performance guarantee, which was a great step towards a booming of P-type PERC mono. And this year, we scale up the gallium doping technology on our silicon wafer to basically replace boron as a dopant, which can also effectively prevent LID and LETID without increasing cost or sacrificing the performance. There are 2 white papers that is available online if you are interested. I can also share with Jonathan in case any emails are sent after the event. Also, you can also type LONGi gallium in Google to find it. But you can see that the test result from the white paper demonstrates a significantly lower degradation than the boron doped perc cell. So one thing that we need to remember that when it comes to module assembly, picking the right material is extremely important. What we do is that we select and verify new material combinations through advanced processes that involves numerous modeling and testing. And we only work with the most reputable and reliable suppliers to minimize the risks, but still put in place strict incoming quality control. It's also verified by different third parties, not only under standard test condition, but 2 or 3 times accelerating a longer time in the test chamber. We've been awarded the PVEL Top Performer and the IETC High Achiever, for example, and we are also certified by TÜV Rheinland on the anti-LETID with their 2PFG standard. On the production line, we also sample and test the final product frequently. This is an example of LID and LETID monitoring result. It's been less frequently performed currently compared to a couple of years ago, as we are now much better in terms of mastering the techniques, and also supported by a comprehensive quality and process control system. So all in all, we agree that the performance in the field is what matters most. This is the latest PV Magazine test results. It's been kind of a competition since 2018 between different suppliers and technology. You can see that both LONGi's bifacial and monofacial module is at the top of each category. And it's even better than some of the N-type modules out there as well. We've also got real projects around the globe that are being monitored from a few kilowatt to tens of megawatt in size for not only energy yield, but also the degradation rate. The feedback we have received so far demonstrates that the average degradation rate is much lower than what we guarantee. So as I said, we are overseeing the whole process and making sure that there are no loose ends that is out of our control. Just to finish, the after-sale service has become a critical part in our business. We have an experienced and readily available team here based in Sydney, Australia, so we can respond to issues in a timely manner whenever they arise. So that's all from me. Thanks a lot for attention.
Well, thank you very much, Richard. And thanks also to Alison. A few questions coming through. Ali, I'll ask you to come back and join us if you can, although we have to make up some time, so I'll keep it kind of short. There was a question, Alison, about different types of cell technology. You've obviously done your testing on PERC cells. What kind of degradation effects, particularly LETID, are we seeing in other perhaps N-type cells like heterojunction?
Absolutely. It's interesting because I didn't say it was PERC cells, but it was. We do see sometimes degradation in N-type and other structures, but essentially because we know it's formed by the hydrogen in structures like heterojunction that don't go through as higher temperature processes, there's less hydrogen, they're going to be less susceptible. And N-type wafers, while they do also show LETID, it is also usually to a lesser extent, and so less impact there. But it is still a real thing, of course.
Okay, and Richard, as I mentioned, LONGi was instrumental in kind of the M6 wafer size, bringing that to the market. Do you see any interrelation between degradation effects or even wider quality issues and larger wafer formats? Of course, we're seeing some really amazingly large wafers coming into the market these days.
Yeah, absolutely. I think it's M10 for now. We're very excited to bring this new product to the market, the HIMO 5, with more than 500 watt panel. Of course, it's more challenging to have a larger area to build a cell based on it. So in terms of degradation, absolutely, we put more efforts into that kind of sector to mitigate degradation, as well as other challenges as well in terms of quality.
Okay, Alison, a question coming through saying that maximum degradation can be expected within 5 to 6 years in places like Queensland. So is it right to interpret that after this time there will be no further degradation? And how long did you perform the study for?
Yeah, so it's a really interesting question, and because there is a huge variability that we see, so that's probably a typical case, but I can't personally guarantee that. I've seen cases like in one of the plots I showed where we can have very different recovery behavior. So just because it reaches, a potential maximum extent of degradation in 5 to 6 years, I can't say that it's not going to stay degraded over the life of the module. It may take a really long time to recover. In most cases, we would see the recovery take longer than the degradation. So it is likely to be a long-term impact, unfortunately.
Okay, so recovery, there is some good news, but yeah, it's a double-edged sword, I think. Alison and Richard, thank you very much for your time. I will keep moving as we are running a little bit behind time. I'll follow up with you, Richard, to see if we can dig into some more details with a follow-up article on PV Magazine Australia. Thank you both very much. Well, we're talking a lot about modules, but of course, it's not just the module that can be the cause of a reduction in performance. As we heard from Nigel Morris, inverters seem to be a pretty big culprit. And beyond that, there's other electrical BOS, electrical balance of systems components that can be the cause of faults, but can also be the cause of some safety issues when it comes to DC cabling. I think many of us remember the fires that occurred on Walmart rooftops in the US last year, and that was related to connectors and DC cabling. So it is a very important part of the equation, not only from a performance standpoint, but also from a safety standpoint. So let's dig into the EBOS, the electrical bulk balance of systems, in a little more detail. Eric Ast has been in the solar industry with Stoibli, I believe, since about 2008, so has been with us for many years. Joins us from Switzerland today at a pretty ungodly hour of the morning. So thank you for making the effort, Eric, and I'll pass the floor over to you.
Thank you, Jonathan, for the introduction, and yeah, good day to everyone. Glad to be attending again. It's a great discussion on quality. It's important for our industry to keep moving forward and learning from failure and experience all of us made through the years. So yeah, I'm from Stoibli. Just trying if the remote control is working. Yes, so I don't want to speak much about the company, but yeah, we are a Swiss family-owned company with more than 125 years experience. I'm in the electrical connector division, formerly known as multi-contact. PV connectors are well known as MC4 types, which stands for multi-contact. And for the history, why MC4 and no MC1? It was because the diameter of the contact was a 4 millimeter diameter. Moving ahead with some real case studies and what I've been seeing in the field, we like to say you can't manage the unknown. We realize, and we have seen over the years, that being known as the original maker for PV connectors, a lot of complaints are coming to us because everyone is calling the PV connector an MC4, so that we see a lot of topics or complaints coming whenever it's related to connectors, even when it's not our products. And we like to say, and after the years and all our experience, we like to say you can't manage the unknown, because a lot of people are putting a lot of attention to models, to inverters, but less attentions to EBIS components, and not only components, but at the end also the way you install them and you use them. So that's why we really see that it's having a high impact on at the end on the profitability and the LCOE, as well as having risk and issues, as you mentioned with the Walmart case. Moving to the next slide, here we have a case. It was a huge plant in Southern America with more than 500 megawatts, and we've been asked by the asset owners to go and check the plant. And one more time, we realized that we have seen a lot of cross mating, so people connecting connectors from different brands together. This is not possible. This is not allowed. This is not working, since everyone is working with different materials in terms of plastic as well as metal parts, so that also tolerances and size are not fitting well, and this is generating issues after some times, and for sure it's having financial impacts. And I think when we look at the next slides, if we see on such a big system like this one, after some really short period of time, that we see and identify a lot of problems that were caused by the connectors. But to go and check one by one all connectors and look at the problem, it's really requires a long efforts and a lot of manpower and impacting cost at the end of the day. And also when we see that high temperature is there, it's quite clear that at the end you'll have a fire effect or a defect connectors after some times. So yes, considering the impact of the connector on the total initial cost, it's really low. And so it's rather important that you pay a lot of attention right at the beginning when you're planning your system to put attention on components, because after sometimes you'll see over the years big problems occurring and let it high impact on the cost. And here it's a study that has been done. It was a project financed by the European Commission on bankability, and we see that the cost per kilowatt peak per year, or loss in terms of money, was quite high, and especially when it comes to problem related to cabling and connectors. And we see here that most of the problem, or the one that are having the highest financial impact, were related to connectors. So here again, here we see some of the issues that are coming over the time of the sister plant, and why it's important to pay attention to connectors and to products. Again, on cross connection, it's really important. I think it's important to say that Australia is well developed in this regards and advanced, since we've seen that this cross connection topic is already in place and has been lived for years, but still we see in the field some issues with people cross mating connectors. And I like to end my presentation with being a little bit fast here. Yes, this is, we've been asked by an asset owner to assess a plant that was already up and running for 5 years, and just looking at the system and the whole cabling, and what we realized, and we looked, so connection between modules were all from the same type and using the same connector, and this is what we could see on the what we call the original with original connectors. And at the end of each string, we had cross connection so that the harnesses that were collecting all the strings were using different connectors types. So we cutted some samples from both model to model connection with original MC4, but as well as connectors at the end of each string, and we did some testing to check the performance after 5 years. And I theory it's quite obvious that yeah, well, on one hand we have for sure contact resistance that is highly impacted, so it's impacted yield and revenue at the end of the day. But if we look installation resistance, which is pretty much more a concern when it comes to safety, we have seen level here when it's even dangerous for people if you come and touch such a connection. It's it could be not only hurt but really be terrible for people. So once again, you can't manage the unknown, so it's really important that you pay attention during planning, during the conception of your system. It's important also that you make sure that your partners, EPC companies and people that are doing the installation are well educated, because very often we see also misuse even when good products and good components are selected. So it's really important that people are well trained and know well people, and when things are done properly at the end, we can save a lot at the end, and on the operation and maintenance sides, and basically then improving the LCOE of your system. Thank you for your attention.
Thank you very much, Eric, for that presentation. And I've got one question coming through, and I will get to that in just a moment. But just at this stage, I'd like to bring Ben Macias into the conversation. He's from Shoals Technology Groups, which has been providing and manufacturing solar components since 1996. He's the VP of Sales and previously worked with a very big name in the Australian market, Nextracker, in the large scale segment. Ben, welcome. Thanks very much for joining us. Of course, we saw some of those EBOS nightmare photos in Eric's presentation. From your side, as a kind of EBOS specialist provider right around the world, why do you think kind of these mistakes continue to be made and some of these faults continue to occur?
Thanks, Jonathan, for having me. So I think there's a couple issues that I think need to happen in order for some of these issues to be mitigated, more notably the connector mismatching. The first thing that I believe that needs to change, or more awareness needs to be brought to, is the module data sheets themselves saying MC4 compatible or MC4 comparable. It's a big no-no, of course, as you just heard from Eric, and shouldn't be practiced. So that's issue number one. We need to make sure that if a module manufacturer is using a different connector other than the original MC4 and MC4 Evo 2, that they put the connector manufacturer of that connector on the module data sheet, as well as the part number. The second thing is just more awareness, like Eric had mentioned, to the EPCs and the subcontractors. They see a data sheet for modules that says MC4 compatible or MC4 comparable, and they just go on Amazon or they go to a local distributor and say, I need 1,000 sets of MC4s. They don't know the difference between multi-contact stall bleed connector versus a company XYZ. Looking at it, to the untrained eye, it's very difficult to notice that difference. So those two things, the former being the more important one of updating these data sheets, is a big deal.
Okay, and Eric mentioned training and the importance of correct installation. How much of that can be kind of simplified, kind of idiot proofing installation when it comes to the EBOS?
Yeah, I mean, it's really just a simple thing. And I go back to the data sheets because that's the thing that we can tackle the soonest and the quickest, and it has the widest reach of solving a very, very common problem. I kind of view, I've spent some time on the structural side. So I kind of refer to the structural, trackers, if you will, as the skeleton of the system. But I refer to the connectors and the cable harnesses as the veins of the power of the flow. And without any power flow, everyone's got some big problems. So it's really important that we have some good veins in our system to transfer this power that we're shooting for.
Okay, well, we've mentioned monitoring, and Nigel gave us some insights there. I think if we move the slide forward one, we had it up earlier. Shoals is introducing some new technology kind of on the monitoring side to provide some more insights on that EBOS level. What can you tell me about that, Ben?
Yeah, so before we release anything to the market, whether that be, and we mainly play in the large utility scale fields around the world, but do play as well into some commercial projects. Before we release any product, it has to go through a couple of years, if not multiple years of R&D and quality and reliability testing before we even release this to the market. So if you go into one of our trade shows around the world, you might have seen the BLM, Big Lead Monitor, up on our boards there, and it's been up there for quite some time, and that's because of the testing that we do to make sure that the product will withstand 25, 30, 35 years of operation, and that's what we've done with this product, and we're about ready to release this to the market. So what this basically is, it's a singular device about the size of your palm, and this can be deployed on residential. So the extreme would be to deploy for one per every module. That would be one end of the spectrum. The other end would be one per inverter block. So somewhere in between is a happy medium that we'd need to discuss with the owners to see what their goals are and what they're trying to achieve. But what this device essentially can do is, at the panel level, we'll be able to monitor the panel voltage, the entire string's current. It will have the ability to do instantaneous IV curve tracing. If the project has a tracker, if you're talking commercial and large utility, it can be mounted on the torque tube or underneath the module to essentially make sure that whatever the tracker is telling you what rotation of axis that it's currently at, what tilt angle it is, that it's actually measuring that correct tracker angle. So this can be deployed, again, either one for every module, one for every other string, one for every block, however you like, but it's a completely wireless solution that system owners, EPCs, installers can utilize to remotely monitor the health of their project at a revenue grade accuracy. So that's a big deal. It's, revenue grade is it's pretty granular as to what we're able to do with this product. It should be, you can use it with your own, our GUI, or you can use it with your own SCADA system. So you can integrate it with whatever SCADA system that's currently on site. So it's got a lot of functionality and then from a velocity standpoint and installation standpoint, which a lot of EPCs have taken interest to in subcontractors, but you essentially can deploy these as you're installing this project in multiple areas if you're using different subcontractors to measure the velocity of each individual subcontractor. So as these get plugged in and turned on, it phones home back and says, "Hello, I'm awake. You're ready to go. Here's the information." And the polling and the timing that it can do, you can do kind of 5 seconds, you can do every minute, you can do 5 minutes, whatever you're willing to look at, how granular you want to get, and polling it's totally up to you. But it definitely allows for a more granular, I'll call it a preventative type of maintenance rather than a reactive after a problem's already happened. And in these large utility scale fields or C&I fields, you might be spending hours upon hours upon hours trying to locate an issue. And with this, seemingly get notified instantaneously as to where the exact problem is. So lots of great things coming for the market.
Yeah, okay, so some more options for some more granularity in terms of that monitoring data. Eric, we have a question about temperature in terms of connectors. Naturally, up on the Australian rooftops in many parts of the country, it's going to get bloody hot. What kind of impacts do you see there in terms of the connectors?
No impact at all. I mean, if we look the data sheet of our products, and especially the kind of materials we are using, they can work and are testing up to 105 degrees C. So it's absolutely not an issue.
Okay, but kind of thermography can be an important tool for either preventative maintenance, like Ben was touching on, but also fault detection. Is that right?
Yes, it's a good way to look at it. Yes, absolutely.
Okay, and why is that? Because the connectors will show up as, you know, burning hot.
Yes, when contact resistance is increasing, typically, then you have increasing temperature of the connection, and when temperature is increasing means you're losing energy. So the question is then, is this temperature increase related to the environment or to the physical or the mechanical connection of the system? And I think the example of Ben talking about the veins or the backbone of the system is really interesting. Such comparison we really like to say also, or to compare the connector with tire on a car. You rather pay attention and look the kind of tire you have on your car, and they rather should fit the kind of car you have, and is really important. And no one will ever mix different kind of tires on a single car. This won't work.
Yeah, good analogy. Oh yeah, sorry, Ben.
One more time, Jonathan, to elaborate a little bit further. But you know, some of the other issues that we see with connectors is that kind of going back to the early 2010s with the virtual inception of utility scale solar, at least in the US, a lot of the connector manufacturers didn't have certifications that they said they did. And it seems like on some of the other components now in EBOS, we're kind of seeing that again evolve, and it's kind of concerning. So if you're an asset owner or you're a developer, long-term holder of projects, please request the authorization to mark on every component that you have in your field. You know, with respect to the connectors, a lot of those connectors are only certified for 4 millimeters square. And the issue with that is that on the inputs of the harnesses, most of those connections or the cabling that's used is 6 millimeters square, and then at some point steps up to 10 millimeters square. So you can't utilize a 4 millimeter square certified product on 6 millimeter square cable and utilize that in the field. And that's happening quite a bit, and it's quite concerning. So whatever product it is, please request the authorization to mark, ask for the documents. It's concerning to see, you know, as we move very fast in technology advancement, that these things are getting missed.
Yeah, okay. Well, that's an important message. Thank you, Ben Macias from Scholes and Eric Ast from Stoibley. There are a few questions for you, gentlemen, on the chat. I'll advise or ask you if you could get to those specifically, because we have to keep moving because of time. Thanks once again. Now, I said earlier that the fourth section of our session today will really dig into the business side. We've looked at some of the complexities that can be introduced when you're trying to detect, analyze, and then claim against warranties, or detect failures, analyze failures, and then claim against warranties. So let's look at kind of some of the business aspects in terms of risk mitigation and liability for the many thousands of Australian installers out there in the market. Dumush Yildiz has been in the Aussie market since about the year 2000, formerly with Solar Matrix, now a part of the Buywork group. Dumush, an important role the wholesaler plays in the Australian marketplace. So please give us some insights when it comes from a quality standpoint, how that role plays out. Welcome today to you, Dumush.
Hello, Jonathan. Hello, everyone.
G'day, mate.
I always wonder why Jonathan does that to me. After listening to all these presenters, how intelligent they are and all the good things they are doing, and saying there comes a wholesaler, all they're interested is flogging stuff. I'll try and make this as interesting as possible for everyone. Yeah, we are basically the meat in the sandwich. So quickly, I'll hope, like with this lag, which we all experience, to see whether I can move on with my slide. Yep, there. So who are we? What role are we playing, and why we care about quality? I'll give you a couple of hints. So as Jonathan said, I've been doing this for a very long time, 20 years. For a couple of years now with BayWa. Just very quick, all what this is, it's a large company, and it will tie in later with one of the other slides why it is important when you're large, what you can do for the quality of the supply chain. We in Australia have 3 offices and multiple warehouses, but what is very nice is to be part of a company which is actually a CO2 compensated organization, and we do also some nice things around the world, which actually feels good. And that was the reason why I started in this industry. Now, what is our role? You have seen these presentations, which are extremely technical. And I think for us, it is to a level of a due diligence, because we do take the financial risk when we buy and sell these products. So for us, we want to, of course, not be exposed. So we're trying do that due diligence and see which companies we can work with. That takes sometimes obviously time to analyze that, and also to find out all these technical aspects, to discuss that internally. Because we are so large, we can talk to different countries and different regions where we have different experiences. And another nice part is with the due diligence, because we do develop large solar farms as well. We can have an input from their end and also operate solar farms and have, again, input from that aspect as well. The other role is the product security. So you can have often a better chance to get to a manufacturer if you buy from a wholesaler, because of the aggregate amount which wholesalers buy. There is a bit more power behind that. Replacement of products can be easier should there be a battle. Does this work? Doesn't it work? There is a certain level of leniency once you know customers, and you determine that their claim is actually valid. And I think also often a smaller installer may not get heard, which helps if you then have that aggregate voice via a wholesaler. And what other important part is the financial security. We do what I just said before. We do help often customers out if they say, hey, look, this is not working, but then there is a battle between the manufacturer and us, that there is actually a valid case, but in the meantime the customer is left without power. So we then step in and support often our customers. Not, I have to admit, not that happens that often, but it on certain levels, what Nigel was presented with inverters, it can happen. Another, for me, very important part of our role is the sharing of information. We do speak to quite a few installers, and I think to share the good and the bad between these parties, installers and manufacturers, is an important role of a wholesaler, to carry that message around and support wherever standards or practices. Another important part, I think, where we play a part, and I think where we, as wholesalers, we all should. We work, for example, with some training providers, and for me, after now 24 years, it is so important to continuously add to your knowledge. It's an extremely fast evolving industry. I mean, we have seen all the other presentations. It is highly technical. It looks very simple in the end, a couple of panels on your roof, but what you need to know now, and that we are becoming actually a major player in the energy security of a country because there is so much solar out there, is very important. And I think with that power comes that responsibility that we need to continue and learn. And why we care about quality, I think we need to care about quality because we work in an industry which is the sustainability industry, and buying and selling quality products is part of being actually a sustainable organization. Another reason is the customer focus. Happy customers are good customers and a good asset, which then add to it. And the other one is an economical decision. Obviously, we all in Australia, I think some of these people who are in this call know what a volatile industry this is and how many companies have come and gone. But I have seen quite a few companies who bet on quality, that they are still there. And I think that is an important part. If you stick to quality, you can stick around for a long time. Just a couple of pictures. I wanted to start my stopwatch, so I'm not sure. Please let me know when I'm going over time. But I thought I have a look on the web what I find with solar modules. As much as the focus was on solar modules, we do get not that many calls for solar modules. But because everyone says, a module is a module, all the presentations before me have actually shown that's not the case. And I think that's what I'm trying to say to our customers as well. There is so many little items in a solar panel which can go wrong, which is forgotten. And that can be the hotspots, the delamination, and all the other things which I have just listed there, which is often not seen. Besides of the fact which Alison probably has spoken about, which people we're not even going to that level, but so there is some obvious items, the individual components in a solar panel. Then going to a lot of other things which have been said before, the balance of system components and also installation practices have been brought to our attention. It really is one of the biggest issues I find in Australia, is that still there is very bad practices here. And we can see how cables are laid, how you don't adhere to clamping zones, which can have an effect. And it does then flow on that, oh yeah, it's not working. And often the manufacturer does not know what the background of this is. For example, here, all these installation practices is really the wrong use of actually a well-manufactured product. And the result is, I mean, the cabling was mentioned before. I have seen cabling which is unbelievable that it works. And again, the responsibility for us is, this is also now a fire causing system as well. So it's not just it sits on your roof and if it fails, it just doesn't do anything. So it can actually be quite harmful and people can get killed. I think there is a lot of ideas. We can discuss that later, but I think we have the standards, we have the guidelines, we have accreditations. What it is now, there needs to be maybe more thinking on the compliance scheme, and maybe changing some of the schemes we have towards a kilowatt hour based remuneration of installation, and not just a blunt payment of a number of dollars for an installation which is not done correctly and may not work after year 4 or so. That would be it from my end.
Well, that's a huge issue to kind of finish on. Dumush, talking about the STC program, perhaps we can have a whole event based on that debate in itself. So thank you very much for that presentation, Dumush. Some of those nightmare photos of installations and failures always capture the attention. Now, moving on to our final presentation for today, Jan Naparakowski has been very patient, and we have mentioned a little bit about liabilities as this growing market and these growing installation volumes come into the market. What kind of liabilities are installers and different market participants carrying? We have a question for Dumush. He'll come back into the conversation a little bit later, but Jan, I'll pass the floor over to you, joining us from Hong Kong.
Thanks, Jonathan, and hello everybody. Thanks for having me in the event. So a lot was really said today about module warranties, module performance, and potential causes of degradation. A lot about individual components. A lot about data analytics, which goes back essentially to proper maintenance and operations of projects. All those components, as well as O&M, they all come with certain warranties provided by suppliers. We specialize in backstopping liabilities arising out of the warranties which those suppliers are providing. So Ariel is a Lloyd's of London syndicate, and we have a dedicated team which is called Clean Energy Risk Solutions, which specializes in providing production, megawatt hour, kilowatt hour, or performance ratio guarantees to solar installations, but also backstopping warranties from suppliers. So I thought, instead of talking about how we backstop supplier warranties and the risks related to particular components, I'll try to wrap around everything by showing a case study of one of our customers who is an installer of distributed rooftop installations, but also larger rooftop commercial projects, as well as ground-mounted solar projects, typically in the size of between 5 to 20 kilowatt for residential rooftop, and probably between 200 to a couple of hundred kilowatt when it comes to commercial rooftops and ground-mounted projects. The goal is to provide a bankable solution which allows companies without strong balance sheets to have a wrap around all the underlying warranties. So, an installer will have all the warranties from the component suppliers, but they would like to come out, and since they install the system, they would like to come out and provide a guarantee on their behalf to their clients, which will be guaranteeing a certain amount of energy production or a certain amount of performance ratio of the system when we talk about larger systems, and be able to backstop this with its own balance sheet. That's unfortunately often not the case. So we started 3-4 years ago. So while we started in 2009 by providing, for example, module and inverter performance guarantees, and we have so far insured over 50 gigawatt of solar modules out there globally. About 3 years ago, we started looking into solar systems and providing production guarantees of those systems. So this particular example, or maybe I should say, if you generally think about wrapping around all the underlying warranties in a system and providing a production guarantee, there can be a twofold effect, or there's two goals which insurance can primarily achieve. One is obviously risk transfer, which is the nature of insurance. But sometimes it's difficult to talk about the risk transfer when you talk about a smaller company, which is just not able to take any risk on their balance sheet, right? So if we look at, I don't know, if we take an example of BayWa's presentation, BayWa has a massive balance sheet. It's a very financially, strong and stable company. Still, it could be there could be a cost benefit for them to transfer certain liabilities arising out of their performance guarantees, which they're issuing to projects, to the insurer, because insurers are working with very large portfolios of risks, and we would have a portfolio of solar performance ratio guarantees, but also 50, 100 other portfolios of different risks, which help us to diversify. So it would be a pure cost-benefit equation question, whether it makes sense to release certain liabilities and certain reserves, which would sit on the balance sheet of a large company. But the other goal, this is the one I want to quickly talk about today, is to enable small companies without those balance sheets to provide warranties and serve the market with investment grade guarantees. So the first case study here is, and there'll be only one case study, is of an European installer who, as I said, is installing residential commercial rooftops. They're guaranteeing 92% of expected kilowatt hours, so of an expected P50 for a duration of up to 10 years. So here the insured event is that every 12 months we will be evaluating along with our customer whether any individual projects in the entire portfolio were prone to degradation below the 92% benchmark. And if they were due to or as a consequence to reduced irradiance, what we call sometimes extensive clouding, or due to a drop in the performance ratio of the system to be defined, we would pay out claims which would be equal to the revenues which the project would generate between the 92% insured event and the actual event. We would fix a pre-agreed amount of Aussie dollars per kilowatt hour for indemnification. And when you look at the insured perils, which I list here as extensive clouding and component performance, those can be very wide. So, we can offer, we do have clients which just insure backstop component warranties and lack of sun. But if we typically move towards more professional O&M companies, installers, and larger systems, we are ensuring the entire waterfall of all the possible performance ratio failure modes, including soiling, design issues, etc., etc. Now, in order to get there, it's important to really look at the entire portfolio. So when we underwrite 100 megawatt system, we just focus on this one particular system. If we underwrite a portfolio of 2,000 rooftop installations, we cannot underwrite 2,000 small systems. So we have to agree on a methodology with the installer or the O&M company on how they predict their kilowatt hour calculations, what are the pre-agreed locations, because we have to map projects into different locations with different irradiance volatility. We have to agree which source of GHI and shading methodology is being used, and we obviously have to make sure that the balance of the system, including the bill of materials of the components, is up to our spec. And very importantly, going forward in the operational phase, we need to agree and endorse the O&M plan, as well as agree to a live monitoring analytics software, which the client will be planning to use in order to verify the claims. And then based on this, we'll define the policy terms, which will be a policy period. For example, 1 year, all the systems installed, built, and commissioned within 1 or 2 years will be seeded into the policy automatically and insured for a period of 10 years. And the premium has to be also simplified. Once we went through our all underwriting milestones, we would just define an amount of premium per kilowatt hour. And at the end of the year, we would just see how many kilowatt hours were guaranteed to all the systems, which would result in the final premium. I think last comment is probably about what we are trying to achieve with that product. Again, I just want to underline that we are trying to provide bespoke, non-traditional insurance solutions. We are not active in the space of so-called property damage, fire, hail, typhoon. Insurance products is our so-called standard traditional insurance products provided by local insurers. One of the traditional insurance products is what is called PI insurance, which is professional indemnity insurance, which is very often required by financiers in Australia. Professional indemnity insurance depends on reinsurance market conditions, and it became extremely expensive, especially in Australia in the last 12-15 months. We are engaging in providing very bespoke professional indemnity, essentially insurers, where we exactly understand the risk which we underwrite, where we exactly backstop specific warranties. And what is most important, we work with data analytics companies to provide automatic claim verification. So, of course, not all claims can be automatically verified. For example, like the cause of a solar module underperforming, we have to go and see whether the module was damaged by hail or whether it has hotspots. But there is a lot of performance ratio failure modes, which we are ensuring, which can be through IA automatically verified on a system level, which allows us to to pay claims within 3 to 4 weeks instead of sending claim adjusters to the field. So our goal is to really provide a cheaper and more and wider in scope alternative to professional indemnity insurance. Thank you.
Okay, thank you very much for that, Jan, and thank you for joining our event. So we can see that there's increasing kind of sophistication and being introduced from insurers to provide protection or to limit liabilities to a range of industry participants. We are a little bit over time, but as our last conversation, I want to bring Jeff Bragg into this event. Jeff, you partnered with us on our first kind of quality roundtable event in Australia, and you've got a wealth of experience in the Australian marketplace. You're currently the managing director of Sunman Solar and serve on a number of different representative roles. Jeff, I want to just ask you, just kind of at a high level, you've heard the whole conversation today. What kind of level of liability or risk does underperformance, does some of these failures and some of these degradation effects and the liability that comes with it, what kind of risk is that to Australian installers and kind of industry participants more generally?
Thanks, Jonathan. Thanks to everyone. Fantastic presentations and really covered this whole subject from many angles and really impressive from all of you. I think that it presents a really significant risk to installers and small solar retailers particularly. You know, the whole thing of PV warranties, long warranties make excellent, you know, marketing, being able to say, look, our product's going to be here in 15 years, 12 years, you know, but that's actually carrying a long burden for solar retailers, you know, small businesses, for example, that are tied to that product. And one of the things I know from just trading in New South Wales under our fair trading laws in New South Wales and Australia, we're basically we're expected to, we are, the retailer who sold the system to the end customer is responsible to make good for the customer if there's a problem. So, you know, sometimes this can end up being at the cost of the retailer if the product manufacturer isn't helpful or is dragging the chain, or, you know, perhaps they're helping by swapping out equipment but not paying the cost of labour to reinstall, you know, replacement equipment. And of course, the retailer is still the one, even if it goes to arbitration at fair trading, who has to make good for the customer. So, you know, the retailer can then go after the manufacturer or the distributor to try and, you know, recoup some of that cost. But essentially, in the end, it's up to the entity that sold the system to the consumer at the end who has to make good for the consumer. So it's a really onerous commitment that one makes when selling products, which of course means, you know, finding fantastic manufacturers who honour their warranties and their processes are simple and clear is a really important thing in this whole process, because you don't want to end up, you know, you don't want to end up in a dispute with your manufacturer. And just for those retailers out there, you know, there are even state-based mediation services for business-to-business disputes. For example, in New South Wales, there's the Small Business Commissioner. I mean, you don't want to have to get there, but it's better off in mediation if you've got a serious issue than to end up in court. But I would just like to say about the sort of consumer context of all of this. In Australia, you know, we've had over the last decade really where the boom has been in terms of rooftop solar for residential. And, you know, that's where the vast number of people have their experience with and where the public awareness of rooftop solar comes from. There is a perception out there that, you know, there are some shonky operators in solar retailing quote unquote cheap products that fail, and then the businesses disappear and there's no backup service. And, you know, if you're selling solar, you're often dealing with those problems, coming back to deal with customers who are looking to solve problems, failing systems, underperforming systems, all of these things. And at some level, I think there's an acceptance in the public that, you know, sometimes they just accept the fact, look, I bought a pup, you know, I've been sold something that wasn't a very good product, wasn't installed well, as Dilmush was showing us. And, you know, in a sense, poor products, poorly installed, and you've got to wipe the slate clean and convince the customer to start again with some quality product and quality installation. So I think that, you know, that context of where the customers are and where people, you know, have this background perception that, you know, there has been some really bad stuff done in the Australian market. And so, you know, whilst I've seen a handful of warranty claims, a lot of those people in that situation aren't bothered with a warranty claim. They just accept they've made a bad decision, bought a bad product, and they're going to walk away from it. So, and of course, if you've been selling top quality product through the right distribution channels with all the backup support that we've been hearing about, then you know, consumers are much less likely to experience those problems. And if there's a warranty issue, then, you know, they can go through that process and get a good outcome. So it's not all disaster, but, you know, there's a sort of background context to it.
Yeah, absolutely. And of course, the kind of Phoenix solar retailers we know about in Australia kind of all too well. Jan, I have a question which I think applies to you, asking why does the 10-year weather part of the performance guarantee come from the installer, or why is it on the installer? Shouldn't the risk of weather be on the owner of the system? Am I reading that correctly?
Yeah, good question. I mean, if we look at the large-scale solar systems which we are insuring, it's usually we are backing O&M providers' performance ratio guarantees, which are adjusted for weather. So there is no weather risk taken into account. If it's the system owner who's reaching out to us to provide a full megawatt hour guarantee, then obviously we include irradiance, but it's the owner who uses it to negotiate with its lenders to get better financing conditions. When it comes to smaller installations and small installers, well, the guarantees with the particular case study, it includes irradiance. It was mostly in Central Europe, in the Benelux, where irradiance is relatively stable. So the installer thought they want to take that risk on their books, so to say. And we thought they had very good methodology to really understand the amount of guarantee which they are giving to their clients, including irradiance risk. So we decided to insure that as well.
Okay, thanks, Jan. Dilmush, a question for you. In terms of performance warranties, we heard from George Taloupas earlier that it can be, often when it comes to degradation, this really falls back onto that performance warranty. We're seeing warranties just generally from module makers getting longer and longer. Do you think there is potentially some risks there in that some people are assuming a performance warranty is perhaps stronger than it is, or more robust than it is, or easier to claim against than it is? Where do you see those kind of performance warranties playing in this equation?
I think in the space we work in, Jonathan, I don't see it, and goes back to probably those presentations and what Jeff said as well. It happens on such a level where it is extremely difficult to prove warranties. Now we are talking obviously from a distribution business in which I operate in. Going into a solar farm space, maybe Richard is better place to answer that from Longi. But I personally find it is extremely difficult. We hardly ever, or actually never, have anyone coming to us and saying it's not working. It is the components itself. If it's either it's failing totally or it's not failing. I had some cases in remote area, a power system for mining operations where you are powering a dedicated load, and that's where you see rather performance issues. But then all those cases were then related to either weather events or soiling, which again is a factor which I think we need to consider quite a bit, which affects the performance. So it is actually a rather an environmental effect on the panel and causes a performance issue.
Okay, and that also relates to kind of preventative maintenance and ongoing O&M. Yeah. Okay, Jeff, I'll give you the last word. We have gone over time. What about, Dumush pointed to the STC part of the equation and the way that kind of regulations and certification plays into this whole discussion. Are you, where do you stand on that, having been in the industry for a long time? Do you think we're moving in the right direction in terms of having those structures in place that lend themselves towards or incentivize quality and long-lived PV systems?
Yeah, look, I think that was a great point from Dumush. I think the concept of, imagine if the STC creation in Australia was based on, like LGCs, on actual performance, it would have been a completely different market stimulus, and it wouldn't have encouraged that sort of bottom end of the market that's just, justifying its existence by the claiming of government assistance in a sense. So I think I think it's beyond changing our small-scale renewable energy target legislation. I don't think anybody wants to go there again. I think just leave it alone. But I think certainly there's an argument for increased compliance testing, expanding of perhaps the CER audit scheme, and just going back to Eric's presentation about the mismatched DC connectors. In my experience, having inspected a lot of PV systems, that's probably the most common error that I suspect is a bit of a time bomb in Australia on residential PV, which is it's everywhere. And it's so simple, and it's an issue of communication to installers about how important that is. So I think that's probably our best targeted bit of training, that one issue.
Yeah, okay. Well, I think that's a good point to leave us on. I saw that Sandy Pulsford from the Clean Energy Council commented early that the CEC does not permit the use of MC4 compatible connectors on the data sheet. So the CEC is taking some efforts there, and they have been a supporter of us with this event. So a big thanks to them. Thank you very much, gentlemen. Thank you to all of our presenters. As I said, thanks to the Clean Energy Council and All Energy for hosting us here today. Thank you to our event partners. Thanks for your participation, the great questions. One final slide to kind of leave us with. I thought we've heard about risks, but we also can see, sorry, that slide before, we can also see this is actually one of the systems that I was previewing right at the start of the event, where there was the suspicion of degradation occurring. And I think the good news is we can see that while power output was dropping off pretty significantly in the first 3 or 4 years of the array's life, that it did begin to recover. And this is actually without any remediation efforts taking place. So maybe that's LeTID coming good under a warm climate, as Alison pointed to. But still much to learn about LeTID. Thank you very much once again. A recording will be available on the PV Magazine website at the end of this event, as will the slides from all of our presenters. So thank you very much once again. Also behind the scenes, that we've had great support from the Reed team from All Energy, and a big thanks to Frederica, to Lucy, and to Marina from the PV Magazine team, who have been instrumental in making this event happen. I'm Jonathan Gifford. Thanks for your attention, and it was a great pleasure to host another quality event for PV Magazine. Stay in touch, and I look forward to holding another discussion like this in the near future.